Hi everyone and welcome to chemistry. This is Mrs. Hutchinson the Great, also known as Chapa. I changed my name a while ago now, but Chapa seems to have stuck, and yes, you best believe it is a pretty awesome name, so you can absolutely call me that, no problem. Now, here's how this is going to work. In front of you, you should have a packet, an entire unit packet. What that means is that it's a packet that you will fill out, and your unit test will be on this particular packet, or 2 packets at most. As we go through this video, what you're going to do is you're going to fill in the blanks as we get to them. Also, I would recommend annotating as I annotate, meaning as I am writing over some of the material, you might want to write that over as well. So you can pause the video if I go too fast for you, and to make sure that you get all of the information down. So, with that said, let's get started. So let's talk a little bit about what is chemistry. So chemistry is defined as the study of matter and the changes it undergoes. So really we have to define what matter is. Matter is anything that has mass and anything that has volume. So it's got to have both of these features in order to be considered matter. So what is matter? It could be you, it's me, it's your dog, it's your chalkboard. Not that we have chalkboards anymore. I don't know why that's what I used. It's your water bottle. It's your table. It is basically anything except for energy. And change involves a transfer of energy. So we've got, remember this law that you may have heard of? Energy can neither be created nor destroyed. Well, we still kind of abide by that law because it's very true. And change involves a transfer of energy. So say we're dealing with a phase change. We're going from a solid to a liquid. We're transferring from one type of energy to another. We're not just creating something from nothing. So that's really what chemistry is all about. It's probably one of my most favorite things because, well, you probably noticed that I may or may not teach it. So I enjoy it a lot. I hope that this year will be as enjoyable for you as it is for me. So let's take a look at this. Now, the value of chemistry. I love chemistry. I've loved it since I was little. I didn't always understand it. It took me a long time to figure out what exactly was going on, but I quickly learned the value of chemistry. So let's talk a little bit about some of the things that chemistry has brought us in society. First, food and clothing. I don't know about you, but this is my number one thing in life. I love food. I love everything about food. And I basically dream about food. And any of you who have seen me probably have seen me eating in school. So now, how does chemistry relate to food? Well, if you think about it, food coloring, for example. Anything that you have that has an artificial color to it. That's chemistry. So let's just click this link here and see and hope that it brings it up. Yay! It does. So let's go over and we're going to maximize this and we're going to scroll. So if we can take a look at these, this is known as a beta-carotene molecule. If you take a look at it though, it's pretty complex looking. It is beta-carotene is found in carrots, hence the beta-carotene. That is the orangish color that we can see. And if you have too much beta-carotene, it may turn your skin a little orange. But best part about that is that's the worst part that can happen. So this is a chemistry-related color. All colors are chemistry-related. They all come from different types of compound. So this is a very interesting article, but the thing that I really wanted to look at here would be this. All of our artificial food colors. Well, we've got blue number 1. Check out this molecular formula over here. It's crazy. It's huge. It's It's got carbon, it's got hydrogen, it's got nitrogen, it's got sodium, it's got oxygen, and it's got sulfur. This is a crazy large molecule, but all of these chemicals and elements put together give us our blue number 1 color. So if you look at all of these are different chemicals. So anytime you are eating with your eyes, if you will, you see something that's particularly delicious looking, thank a chemist, because that has to do with the chemistry of the particular food. So if we go back, so let's go back to our look at this. I'm so good at this, let's be honest. So going back to our slides here, we also have clothing. Clothing is extremely important. Why? Because, well, without chemistry, without clothing, we would all be sitting next to one another in our birthday suits, which gets a little awkward, by the way, I have found, just personally. So thank a chemist for the clothing that you're wearing. But this company, known as Columbia, you may or may not have heard of Columbia, it is a company that we use way up here in the Northeast. They've come out with 2 different types of clothing. We've got our Omni-Freeze clothing. It's pretty cool. It's pretty interesting. It is sweat activated cooling clothing. So it basically, what it does is the hotter you get, the cooler your clothes are going to feel and make you. So I can play this video on here. It may be a little glitchy, but I'm going to do my best. I'm going to maximize it as well. So let's try it.
Omni-Freeze Zero is the industry's leading cooling technology and is the latest innovation in Columbia's commitment to keeping it cool. The Omni-Freeze Zero Blue Rings concentrate a cooling agent close to your skin and capitalize on your sweat to lower the overall temperature of the fabric, accelerate the wicking process, and provide an instant and prolonged cooling. This sweat-activated cooling technology is our coolest invention yet. It's how hot people stay cool.
So it may have been a little glitchy. I don't know if the video actually played all the way through on this recording, but I think you could at least hear it. But basically what it does is the chemist infused this particular material with cooling molecules that as you get hotter will start to emit a cooler temperature, thus resulting in you feeling cooler, which is kind of awesome. Check these out. They're actually pretty neat. They're expensive, of course, you know, but it's a pretty cool product if you want to think about it like that. So let's go back to our slides and let's take a look at Omni-Shade clothing. So what is Omni-Shade clothing? Omni-Shade lets you do exactly what they say here. Enjoy the sun safely. What this clothing does is it blocks UVA and UVB rays, and it helps you prevent sunburn and long-term skin damage, which, as you know, long-term skin damage can cause melanoma and can cause cancer. So what I'm going to do is I'm going to play this video and hope that it's not quite as glitchy, but we don't really know if it is or isn't. So let's try this.
With Omni-Shade, protection takes 2 forms, making fun in the hot sun a more comfortable experience. Using a UV lamp to simulate sunlight, we've placed clear UV absorbing beads under a swatch of Omni-Shade fabric on the left and under a swatch of industry standard fabric on the right. After a few minutes under the lamp, the Omni-Shade fabric has protected its clear UV beads. However, the UV beads protected by standard fabric have drastically changed colors, demonstrating possible skin damage. Omni-Shade, the coolest sunblock around.
So again, it's pretty cool. I don't know if that video played, but you can always check out this particular website here if you want to actually watch the video. It's really awesome, just like you could if you wanted to check out the other website for the Omni-Freeze. You can check this out and go and take a look at that. But what OmniShade does is they just infused the material with particular chemicals that have the ability to protect you from UVA and UVB rays. So if you happen to buy this clothing, thank a chemist, because they saved you from hopefully getting skin cancer, which is not quite fun. Melanoma is not an ideal thing to get. So let's go back here. Now also, thank a chemist if you've ever had a headache. If you've ever had the need to take Tylenol, or if you've ever had the need to take aspirin because of the fact that you maybe sprained an ankle, thank a chemist. Otherwise, you would still be in pain today. Biotechnology, thank a chemist. If you have a prosthetic, they come up with the materials that will make your prosthetic for you, or prosthesis, a little more comfortable. Electronics, anytime you've used your technology, anytime you've used your cell phone or your computer, or the computer you're probably using right now, thank a chemist. Solely because there's chemistry that's happening within those electronics. And we're going to get to that when we talk a little bit about electrochemistry later on in the year. Engineering and technology are pretty self-explanatory. Environment. So thank a chemist anytime you are going outside and you're actually enjoying your environment, because there are many, many different things, a plethora, if you will, of things that affect our environment, and our chemists are out there to help us keep it as pristine and clean as we can. Aerospace, if you enjoy rockets and going into space, thank a chemist, because the reaction that gets you into space was discovered by chemists. And of course, if you enjoy being human, thank a chemist, because your body does a ton of different chemical equations, or chemical reactions, I should say, as you are breathing in and out, as you are running, as you are thinking, your neurons are firing. So chemistry has a lot of importance in today's society. So before the scientific revolution, basically before the 1500s, well before any of the teachers in this school were born. I know it's kind of hard to believe, but people believed only what the ancient Greek philosophers and their religions stated. Basically, this thing called no questioning. They never questioned anybody's beliefs, which is kind of hard to believe. I mean, knowing our society and probably knowing some of you, you question a lot of things that happen to you, around you, or near you. But back in the 1500s, people just believed really what the scholars told them. And the scholars just kind of came up with the stuff off the top of their heads. They really didn't use much of anything scientific or out of the way of observations to help us figure out what's really going on. But then something extremely important came along, and that is the scientific method. We have Francis Bacon and René Descartes. And what they did in the 1600s was they came up with a systematic, rational approach to science that relied on these two very important things: observation and experimentation. Now, observation is very important. What they did is they sat down and they looked at the world around them, and they made just notes on what they observed. They said, hey, grass is green. Grass grows every day. Why does it grow every day? Why is the sky blue? They just looked around. And when they came up with a question, they developed ways to actually test their theories and figure out whether or not it was always the case or just that one particular time. So the scientific method has a lot of importance in how we do science today. So one thing that we do for the scientific method is we use observation and measurements. So there are two different types of observations. We've got quantitative and we've got qualitative. So quantitative. What quantitative is, well, think about really what it kind of sounds like to you. Quantitative. Sounds like quantity, probably is what I'm guessing many of you have said. So yes, quantitative measurements measure the quantity of something. So it measures the volume or the mass. Okay, so anything, whoopsies, didn't mean to make that. It basically just measures something explicitly. Whereas qualitative measurements, they measure the quality of something. So, what is quality? How do you actually measure quality? Well, you can measure odor, you can measure color, you can measure basically what you observe, what you are seeing. That is the qualitative measurement. But both of these measurements require tools. That was the important thing here. When we had the scientific method, when that was finally invented, we now needed tools. So, that was the beginning part. Now we're going to really talk about inference versus hypothesis versus, not sure how that happened. Inference versus hypothesis versus observation. So an inference, I'm sure you've heard of what an inference is, but let's think about it a little bit. So an inference, what is it? What is it? What is it? Well, if you infer something, really break the word down. If you are inferring something, what do you think that means? Just think about it. Now, an inference means when you bring over past experience into making a judgment. Basically, you're making your observation or your judgment and based upon previous knowledge. So, you bring your past experiences into making a judgment. So when you infer something, that's what that means. That's what an inference is. If we compare that to a hypothesis, when you're making a hypothesis statement, what does that mean you are actually doing? How are you actually writing a hypothesis? Do you know? Me either. No, I'm just kidding. I know. So when you are writing a hypothesis, what that means is it's an if-then statement typically. So what an if-then statement is it's a statement based on previous observations that can be tested scientifically. So it's a statement based on observations that can be tested scientifically. So that's what a hypothesis is. Inference based on past experiences. A hypothesis is something explicitly that we can test. So, what is an observation, though? Well, an observation is what we describe our environment looking like based on our five senses. So, most people make observations during a lab itself. So, it's a way to describe your environment using your five senses. So that's really what an observation is. That's the difference between an inference, a hypothesis, and an observation. We're going to be using all of these this year. We're definitely going to be making lots of hypotheses, and we're definitely making observations every single lab. Just what we do. Okay. So now, we're going to move on to experiment. Experimentation. We've got two things here. We've got our control and we've got our variables. So our control is the thing that we change. This is what we are altering, what we are changing. Oh, and by the way, I do abbreviate a lot. So triangle equals change. In case you're wondering. Yeah, I need like a book on all of my abbreviations. And the variables that we're talking about are either our independent or our dependent variables. So a great way to really remember independent versus dependent variables, the way that I tell people, is I have a little acronym. It's mix and it's dry. So mix really stands for manipulated is our independent variable, dependent, and that goes on our x-axis. Dry stands for dependent, meaning it's the responding variable, and that goes on our y-axis. So, if we say that something is manipulated, that means that it's something that we controlled, something that we altered. That's known as our independent variable. The variable that is responding to that change, that's our dependent variable. So just a handy-dandy little way to remember this. And then after we conduct our experiment, we go to our analysis and conclusion with reference to our hypothesis. You always, always, always have to state, I accept or I reject my hypothesis. You never prove a hypothesis. You either accept or reject it. So now, last thing that the scientific method helps us with, they can help us discover theories. What a theory is it's something that is testable. Typically, it's a mathematical model. It's very logical. It helps describe the how or why something happens in society. So we've got our theory of relativity, and I put the websites on here. I'm not going to click on those links, but they're pretty important if you want to take a look at them. But Einstein came up with our theory of relativity. It's a pretty complex theory. But then you guys know a little bit of something about this guy named Darwin. Darwin came up with our theory of evolution, and yes, I changed colors because I just figured out how to do that. You're welcome. So he came up with our theory of evolution. That's also a pretty cool theory. You might want to check that out if you don't remember it from bio. But the difference between theories and laws is that laws are statements of truth, meaning in any situation, whenever you encounter these laws, they will always ring true. Whereas our theories try to explain something, but as much as we test them, we can't really figure out, are they actual truths? So our laws of thermodynamics, those are pretty important if you take any kind of engineering course. But then we also have Newton's laws of motion. And this is what we are going to be learning about in physics when you take it, because I know all of you are going to take physics because you're going to enjoy this class so much. So Newton's laws of motion, they're pretty cool. You've heard of them. You've got inertia. You've got for every action there's an equal and opposite reaction, and force equals mass times acceleration. And of course there's solutions for everyday problems too. So that seems to be enough for today, for this particular lesson. I hope that you enjoyed learning a little bit of something. But what I want to show you is what worksheet you're going to work on. It's the what is chemistry all about worksheet. Who knew? And you're going to answer all of these questions. So you do not, however, need to answer them in complete sentences. And how this is going to work is you'll answer these worksheets. The sub, or myself, I should say, not the sub, that's silly. Me, I will have the answers ready for you, and then we can go over them and we can discuss them, and you can check your answers. Of course, for the first one here, my guess is probably the answers that I have on there are vastly different from the answers that you have on there, because I tend to think very scientifically, but some of you may think very outside the box, and it'll probably be a pretty interesting conversation. So I want you to work on this worksheet now. If you need to review the video at any moment, just play it again, and I will see you in the next video. Have a good one.